Okay, so on example number 8, it says, with the help of scientists, farmers in France have been able to produce more grain each year on the same farms. Here are the crop yields for several years. So it starts with 1963, goes through 2007. You can see the increase there in the units are kilograms per hectare. The improvement in crop yield can be described by the equation. So they give you the model here. You don't have to find the model. Yes, they give you the data, but you don't have to find the model. They give it to you. So in this case, it's a quadratic function where x is the year and y is the grain yield in kilograms per hectare. Now, it's very important that you read when you're doing problems like these. You need to know what the variables stand for. So I highly encourage you to underline or whatever you need to do. So I would underline that x is the year, y is the grain yield in kilograms per hectare. You need to make sure, and the reason why I want you to do that is because sometimes they will change the units. So you got to make sure that you're using the correct units when you plug things into the equation. All right, so first question here is, what does the y-intercept of this function represent? Well, let's think about this for a second. The y-intercept occurs where? What happens when x equals 0? So y-intercept means x equals 0. So x in this case is the year. So the y-intercept would be the yield in year 0. Now, this one's a little weird because if we look at what that y-intercept would be, if we plug in 0 into our equation, it's negative, 4,210,000. Okay, so obviously we're not going to have negative yield, but it has to do with, this is just a model to represent the data. It doesn't always represent all of the data, so you have to keep that in mind. Okay, so according to the model, what was the crop yield in 1994? That's a year, so that's an x value, so we need to plug that into the equation, and it says to round to the nearest whole number. So we're going to plug 1994. I'm just writing it down so that when you look back at your notes, you know where that number came from that we're about to get from the calculator. It's not very helpful when you just have numbers that appear, right? It's helpful to see where they came from. I don't know why my computer's being slow today. All right, so plugging that into the model that they gave us, times 1994. Another thing that they will frequently do while I'm typing this in is that they will not necessarily plug in the year itself. A lot of times, did I get the right number of zeros? 4 zeros, yeah. A lot of times they will say that year 0 is whatever year you start with. So a lot of times they would say year 0 is 1963. They did not in this case. But just be aware of that. Sometimes they do that. They did just say that X is the year, so you do plug in 1994. So let's see here. That is, we need to give it units. That would be kilograms per hectare because that was the output. The Y is the grain yield. Now, that's according to the model. Did I type everything in right? It's not looking. Okay, cool. I typed everything in right. Now, the reason why I'm asking myself, did I type that in right? Because 1994, that fits in the data that they gave us, right? 1994 is between 1986 and 2001. And we don't even, in 2007, the data that they give us, we don't even get to, it's just over 7,000. We don't get to 9,000. Again, this is the limitations of your model. It fits, but it doesn't always accurately represent every single data point. Okay, so assuming that this trend continues, what crop yield is predicted for the year 2035 by the model. Again, that's exactly what we do in B. So I'm just going to write plug in 2035. I'm not going to take the time to write all that because then I'm going to go to my calculator. I'm going to press second enter, and I'm just going to replace 1994 with 2035 instead of having to retype all of that information. Okay, so again, 11,000 to, we'll say 201, I guess. We should round that. Eraser, there we go. It's getting a bit slow to surely. 2 kilograms per hectare. Okay, so we didn't take the time to come up with our own scatter plot since they gave us a model of best fit. So based on this information, I don't know that a quadratic model is really the best fit because it seems like the prediction there, particularly for 1994, is kind of way off. So that's just something to keep in mind. It's not necessarily the best fit model that they gave us. Okay, the last one. The model indicates that a crop yield of 7,000 kilograms per hectare was achieved in what year? So this is flipping it around. It's telling us what the yield is, and we need to find out what year that occurs in. Now, depending on what kind of equation you have, sometimes you can do that by algebraic means. Sometimes you're going to have to rely upon technology. In this case, because it's a quadratic equation, we're going to rely upon technology. Because, yes, normally we would subtract the 7,000 so that we can factor. Obviously, I'm not factoring with a decimal. I don't know about you, but I'm not playing that game. So then our other option is quadratic formula. I don't really want a quadratic formula with 4 million in there. So I'm just going to go with graphing. So let's go to Desmos. Now, graphing works in any situation, but if this were like an exponential equation, I would expect you to solve the exponential equation. Okay, you should be able to solve the exponential equation using logarithms, but because this is quadratic, the algebraic methods that we have would be a little bit more involved than necessary. Okay, I think I got all those zeros in there. 1, 2, 3, 4. Yeah. Okay. So obviously I can't see anything because it's way out there. I'm going to fix my scale because remember we're talking about years here. We're talking about years. So I'm going to start with the years that they gave me: 1963 to 2007 for my x's. For my y's, I'm looking for where it crosses 7,000. So I'm going to go 6,000 to 8,000. And there my graph appears, so I can see where they intersect, and that tells me 1970. 1970 is the prediction here. And does that agree with the model or with the actual data? Not really. Actual data in 1970, it should be somewhere around 5,000. So here's a really good example of a model not exactly fitting the data super well, but that's what they told us to use. So that's what we're going to use.